All right, so technique number 2 of integration is integration by parts. We can find the antiderivative by guessing and checking. Okay, so that works for anything. If you can guess and check, by all means, right? Also, we can use substitution. So we have a technique. If guess check doesn't work, we have a technique. We've done substitution with trig. We've done substitution with non-trig. But how do you undo the product rule? So let's take a look. Just say if h of x, some function, is the product of two functions, then what's h prime of x defined as? So we know that it's the first function times the derivative of the second function plus the second function times the derivative of the first function, right? That's just basic product rule. Which means that h of x itself, so if I want h of x, then what I need to do is take the integral of this, right? I need to undo what I just did. And integration undoes differentiation. Plus g. Okay, and if we're going to take the integral, then I have to do the old gx thing. Which means that, well, h of x is f of x times g of x. So, okay, so what do? We took h of x was f of x times g of x, took the derivative. I want to undo the derivative, I take the antiderivative. H of x is the same as this, which means that that product is the integral of f of x times g prime of x dx plus the integral. Now I'm just splitting up the integral g of x times f prime of x dx, right? So these two things are the same. They're equal. Which leads to, so if I isolate this, the integral of f of x g prime of x dx, so that's going to be equal to this minus this. So it's going to be equal to f of x g of x minus the integral of g of x f prime of x dx. And so that's how we're going to take the integral of a product, this product, right? If it's expressed in this form. Find the integral of a product. Now, we could do this using u and v notation. So f of x, that could be the function u. Then g prime of x is dv. F of x is u. G of x is v. F prime of x is du. And g prime, or g of x, oh wait, sorry, it's the f, clean that up. These two together, the f prime of x, that's du, and g of x is just plain old v, which on the formula sheet comes out as the integral of u dv is equal to uv, right, so the two functions, minus the integral of v du. And also comes out, so this isn't exactly on the formula sheet, it comes out in this form. The integral of f g prime is equal to f g minus the integral of g f prime. So these are the two forms that are on the formula sheet. I'm going to more or less stick with just the u dv, that form, right? So you've got this or this. And again, it's the same deal, right? Two functions, uv, their product, integral. So the way that this is written then, so integration by parts, what we need to do is one part of this, so if we're looking here, one part of this is a function and the other part is the derivative of a function. Okay? Which means when we look at this, one of these guys, either x dx, right, that would be the integral, and then e to the x would be the function, right? So we have a function and a derivative. So we have a function and we have the derivative of a function. So if this is the derivative of the function, this is the function, or we can treat them as this is the function and this is the derivative. So we need to choose. So one part of this, so up here we just say, look, one part of this becomes f of x or u, right, using this, so it's f of x or u. Well, the other part becomes, becomes g prime of x or dv. So here's what we want to do. Here's the strategy we want to adopt, right? We want f of x or u to be something whose derivative is easy to find, right? So if I say u, I also know that I need du, right? So one of these parts becomes u, we work out du. The other part is dv, so we need to find its integral, right? So we need one part of the function. All right, so we want f of x. We want f of x or u to be something whose derivative is easy to find. To be something whose derivative is easy to find. Okay, so one of these guys becomes u, we have to work out du. And the other one, and g prime of x or dv, hopefully you can squeeze this in. G prime of x or dv has an antiderivative, derivative that is not hard to find. Okay, so we need four things, right? We need u and v and du and dv. Now, we're not given this. Right? We're given this. This is the formula that we're then going to use, right? We're going to say this integral is equal to the original function u times the function v minus the integral of v du. So when I choose one of these guys, either x or e to the x becomes a function whose derivative is easy to find, and then either x or e to the x becomes the function whose antiderivative isn't that hard to find. And in some cases, it really won't matter, right? Like in some cases, like, yeah, it's easy to find the derivative of this, or it's easy to find the antiderivative of that, right? It's not a problem. Okay, so here's how we start off here. Say which function, okay, so we've got x and e to the x. Which one's got a derivative that's easy to find? X, okay? So we're going to say u is equal to x, which means that du is equal to what? So what's the derivative here? 1, so it's just 1 dx, right? So it's just dx. So du is equal to dx. Having chosen that, that means that this guy, e to the x dx, that's dv. So dv is equal to e to the x dx. So now we need to get v, so we need the antiderivative of this. So what function has a derivative that's e to the x? E to the x, right? So generally speaking, if you see an e to the x in there, you want that to be your dv, right? It's very easy to... Okay, and now all we do is we write out the formula. It's on the formula sheet. It says that u dv, the integral of u dv, is equal to u times v minus the integral of v du. Okay, so at this point it's just a substitution into the formula. So the integral we want to find, we don't write this. This is the integral we want to find is equal to the function u, which is x, times v, which is e to the x, minus the integral of v, which is e to the x, times du, which is dx. And so now we have one more step. So this just stays, right? There's nothing you're doing with this, but we need the integral of e to the x dx, which is e to the x. And we got to toss in a plus c, right? Because we're doing general antiderivative. And that's it. We're done. So in other words, if you take the derivative of this, that's what you're going to end up with. All right. Same thing over here. Maybe I shouldn't have done that. Okay, so we got to choose which one's going to be u, which one's going to be v. So two choices are, you got x and you got cos 2x. What's the easiest one to find derivative of? X. So we let u equal x. And what's du? 1 dx. Which means that dv is equal to cos 2x dx. So is cos 2x easy to find the antiderivative of? That's not so bad, right? What is it? 1/2 sine 2x. Right? Because I want the derivative of this to be that, right? So antiderivative. So just say, well, okay, I know I got to have a sine 2x. The derivative of sine 2x would be 2 cos 2x, and I don't want a 2 here, so we throw the half in. Okay? So that's the 4 things we need. Then we just plug them into the formula. So I'll write the formula like one more time, and then we'll maybe stop writing. Or maybe every time I do this, I'll write the formula. It just reminds me. So you're looking at your formula sheet. This is on the formula sheet. Copying that down. We're not interested in the left side. That's what we want to find. We're interested in the right side. Okay. So the left side is this. Okay, so what's that equal to? U times v. So x times 1/2 sine x times 1/2 sine 2x. Minus the integral of v 1/2 sine 2x du, so du, which is dx. So we've got 1/2 sine 2x dx. Okay, left side easy, right? I mean, that's just going to become x over 2 sine 2x. So that's just doing the multiply. Right? Nothing hard there. And now we need to find the antiderivative of this. So we've got minus, we've got 1/2. So we'll pull the half out front here, and we need the antiderivative of sine 2x. We start off by saying, well, the derivative of cos 2x. The derivative of cos 2x is going to be 2 times minus sine 2x, and right, I don't want that minus, or we'll take care of that. So I'm going to go minus 1/2 cos 2x. Okay, again, so ignore that, just take the derivative of that. It's going to be 2 times negative 1/2 times times negative sine 2x, and the 2 times, okay, that's that. And we'll combine these guys right now. So x over 2 sine 2x minus minus will give you plus 1/4 cos 2x. And the capper is what? Plus c. Okay, so don't forget the c. You or your partner, right? The partner quiz. One of you better remember plus c. You can decide that at the beginning. You're the plus c person or you're the plus c. Make sure we put a plus c. Okay, question? Continuing on. Remember this guy? So this was on the sheet the first day that we did antiderivatives, right? And it was like, can you guess what the antiderivative is, right? And I'm guessing most of you didn't figure out what the integral. Most of you didn't figure out what's the integral of this. So here's how we do this one. Does that look like a product? No, right? So we're going to write it as a product. And the product is going to be ln x times 1. We're going to say, well, what's u going to be? Yeah, u is going to be ln x, right? In other words, we end up with a 0, and that's just not really going to work this out, right? So u is ln x. What's the derivative of ln x? 1 over x dx. That's du. Which means that dv was 1 times dx. So what's v? What's the integral of 1? X. Or what's the derivative of v? 1 times dx, right? I mean, the derivative, so however you do this. All right, so what's that equal to? Well, again, so we've got the integral of, well, I'm not going to write out the formula anymore. Why would you do this? So the integral of ln x dx is equal to u times v, so ln x times x. Let's write that as x ln x. If I write it as ln x times x, somebody's going to be convinced the next line is ln of x squared, which is not true. Okay, so it's the product of u and v minus the integral of v, which is x, times du, which is 1 over x dx. All right, so this is x ln x minus the integral. What's x times 1 over x? Just plain old 1, so this will be 1 dx. What's the integral of 1? X. So we got x ln x plus x plus c. So that's the integral of ln x, right? You take the derivative of this, you'll end up with 1. Oh, sorry, minus x. Yes, my bad. Minus x plus c. Because if you do the derivative of x ln x, you're going to get a plus x sitting in there, and then we got to get rid of that minus
here, Bernie's going to debate Trump.
Bernie's going to beat Trump.
No, Bernie's going to debate Trump.
Oh, he's going to debate Trump.
Yeah, he is.
What is this slide?
No, because this is on Jimmy Kimmel's. I'll be Jimmy. Is it Kimmel or Fallon? There's two.
I don't know. There's two Jimmys.
He said yesterday on the interview, he was like, I think Schneider has been treated very unfairly by the PNC, and I should debate
See,
him.
now this video will be dated not only by the date that's on it, but by the conversation that's going on.
Oh, you're recording?
Yeah, it's being recorded.
Oh, no.
Okay, so we can split this up, right? The integral of a sum can be expressed as the sum of integrals, right? And this guy here is easy to do, the 4x dx, right? So in this case, we can split it out as the integral of a product. And so we're now going to use integration by parts to do this integral. And we're just going to use plain old integration techniques to do this one, right? Okay? So we can split it out. So for this guy here, we're going to say, okay, so u is equal to ln x. And then du is 1 over x dx, and dv is equal to 5x squared dx, right? Because you don't want to say dv is long. We just learned this, right? And you don't. That's not an easy thing, right? If you say dv is this, then you've got to go x ln x minus x. Don't want that. This is much easier to find the derivative of, and this 5x squared is much easier to find the integral of, which is what? So add 1 to the power and divide by 3. Yeah, so b is 5/3 x cubed. Okay, so this guy is going to be done by integration with parts using this information. So that's equal to, okay, so integration by parts says u times v, so ln 5/3 x cubed times ln x, u times v, minus the integral of v du. So we've got 5/3 x cubed times du, which is 1 over x dx, plus this, right, the integral of 4x dx. So this is just being done by normal. So we had a sum. Within the sum, we recognized, hey, there's a product. Okay, so I'm going to use integration by parts on the product. We're going to split this up as the integral of this product plus this integral, which is just kind of trivial. Okay, so this, nothing special here, right? It's just 5/3 x cubed ln x. And this, well, we'll go one more step. So this simplifies to what? 5/3 x squared dx plus, and we'll just leave this as an integral still here. And then on the last line, we will take the integrals. So 5/3 x cubed ln x minus, okay, what's the integral of 5/3 x cubed? So sorry, 5/3 x squared. Okay, so this is going to become an x cubed, right? But we're going to have to multiply by 1/3. So 5/3 will become 5/9. Okay, this is going to have to become x squared. And what's going to go in front to guarantee me a 4x squared? It's going to be a 2. So plus 2x squared plus c. Good. If you both forget the plus c's, you're just going to lose a half mark each time. Right? Like there's 2 of you, so I have, it's like a half mark for you and a half mark off for you. Half mark off for you. Okay, so there we go. Use integration by parts twice. Twice. What the heck are they talking about? Use it twice. So here's what they're talking about on use it twice. So we look at this, we say I got a product. It is not immediately obvious to me what the integral of this is, right? So guess and check is probably off the table. All right, so we say, well, we're going to start off by saying u equals x squared. So du is 2x dx. And dv is e to the x dx, right? Because if you ever have an e to the x there, that's very easy to find the integral of, right? Or the, yeah. And that's just plain old e to the x. All right, so we throw that into the formula and we say this is equal to u times v, so x squared e to the x, minus the integral of v, e to the x, times du, which is 2x dx. Well, what's the problem? The problem is, this is a product. So we're going to do it again. Right? We're going to do integration by parts. So we did it on this is a product. We did it, okay. So we got atoms. Got to do it again. You've got another integral to find. So let's kick over here. All right, this time, u is equal to 2x, and du is equal to 2 dx. And dv is e to the x dx, and so v is e to the x. So now we can come back down. So all right, we've got x squared e to the x minus, we're going to do the same thing again, right? So it's integration by parts on this product. So in here, what goes is u times v, but that's for these guys, right? So it's 2x u times v minus the integral of v, e to the x, times du, which is 2 dx. Okay, this one we can handle, right? We don't need to do integration by parts on that. Okay. Leave the whole thing up. Okay, so we did integration by parts, and we ended up with another product, right? We had to do the integral of a product. How do we do the integral of a product? We do differentiation by parts. So we did this. Okay, what have we got now? Well, we've got an x squared e to the x minus, okay, in here we got a 2x e to the x, and can we do the antiderivative of e to the x times 2 dx? So basically the 2 just kind of kicks out, right? So it's just going to be minus 2 e to the x. Okay, and then we can throw in a plus c. on the end, right? And again, it doesn't matter what your c. If you threw the c in brackets there, maybe it's a different c. Okay, so what do we got? X squared e to the x minus 2x e to the x plus 2e to the x plus c. Okay, that's it. There's no like terms. You can't collect any of these guys together. So when you do an integration by parts, you might have to do an integration by parts again. Okay, again, how do I know I'm going to have to do that? I've got another product. X squared sine 3x. Okay, what's u? X squared, right? Easy to find. So u is something you want that's easy to find the derivative of, and dv is something where it's not hard. It's not necessarily easy. That's why I said, I don't say it's easy to find the answer, I said it's not hard to find. It's usually a bit harder. What's du? 2x dx. Okay, what's dv? Sine 3x dx. What's v? Yeah, I should left some room for the negative sign. Yeah, so v is negative 1/3 cos 3x. So one is either you or your partner's job. Whoever's remembering the c's, the other one remembers that the antiderivative of sine is a negative, right? So keep our signs correct, right? So you got to decide that at the beginning when you sit down. It's like, I'll do the c's, you do the antiderivative of sine is negative cos. I don't know. It's like probably on one of those days. Okay, anyways, what do we got? So the integral is u times v. So x squared times negative 1/3 cos 3x minus the integral of v, negative 1/3 cos 3x times du, which is, so if you like, throw those 2x, 2x dx. Equals. Okay, so this is easy, right? I'm just going to go negative x squared over 3 cos 3x minus, all right, and what are we going to do here? Like, hey, we got a product. So we're going to do it again. So we're going to go up here and we're going to say u is equal to 2x and du. Or wait, okay. So actually we have a number of choices at this point. We have a 2/3, right? Really got a 2/3 here. So we can make u equal to 2/3 dx. So you know what, before we do that, let's simplify this down a bit. Minus the integral of, so we've got, okay, it's minus a minus, so it's going to be plus. Then this will be 2/3 cos 3x dx. 2/3 x. Hang on. 2/3 x cos 3x dx. Now you got a choice here, right? The 2/3. We can either pull the 2/3 out of the integral, right? Just toss it in front and say 2/3 times. Or we can let u be 2/3 x and then just deal with it there. So what's your choice? Move it out or move it out? Okay. So one more line then. Let's go negative x squared over 3 cos 3x plus 2/3 times the integral of x cos 3x dx. Okay, this, another product, right? So then we're going to go u equals x, du equals dx, dv is cos 3x, cos 3x dx, and what's v? 1/3 sine 3x. Plus or minus? Plus, right? One of your jobs is to remember that's a plus. You got to get the signs right on these things. Other person's got to remember at the end we got to put a plus c. Okay. All right, so we've got negative x squared over 3 cos 3x plus 2/3 times, okay, and again, so this was a product, we're doing integration by parts, formula sheet, u times v, so x times 1/3 sine 3x, minus integral of v du, so 1/3 sine 3x dx. All right, so the first part, which is just along for the ride. Okay, so here we get x over 3 sine 3x, and here we get what? Oh wait, that's a sine 3x. How come somebody didn't say it? What's it? Sine 3x dx. So we're just flipping back and forth between cos and sine, right? But what's that going to do to this? It's going to be a plus, right? So plus, we're going to have a cos 3x. What goes in here? 1/9, right? So we're not worried about the 1/3. It could really be here if we wanted to. So the antiderivative of sine 3x is cos 3. Oh no, it's minus cos 3x. So this will be minus a minus, so plus 1/9 cos 3x. And now we throw the 2/3 in. Oh right, and since we've taken, yeah, so plus c. It doesn't matter where the plus c goes, just that it goes. Okay, so negative x squared over 3 cos 3x plus 2x over 9 sine 3x plus 2 over 27 cos 3x plus c. And amazingly enough, if you wanted to sit down and take the derivative, that's going to come out to be, right? Like these are in no way, shape, or form sort of obvious. Like, hey, I take the derivative, I'm going to get that. But if you do actually take the derivative of that, you will get that. Okay, so obviously stuff would cancel out there, right? Like things, because I need to end up with x squared sine of 3x, right? Okay, I got all that stuff. Okay, before we do the cool one. All right, leave that up for a second. You can, here's the cool one. E to the x cos x dx. So in this case, what's u? Well, we've got a choice here. I mean, it's easy to find the derivative. It's, I don't know, you could try it either way, right? I don't think it's going to make necessarily a huge difference. But in this case, here's what we're going to do. We're going to let u equal e to the x. Then du is just going to be e to the x dx. We're going to let dv equal cos x dx. And then v will just be sine x. We make a difference. I don't know, we can do this both ways and just see what happens. If we, that sine x is positive because the derivative of dv, the derivative of v will be cos x. Positive cos x. Okay. Okay, so you're the, remember the plus c part. Right, sit down with your partners. I do the plus c. I got the sine. So when you're doing this, just take the derivative of that, right? Anytime you do an antiderivative, do the derivative, especially with sine and cos, right? It's a lot easier to remember. You know the derivative of sine and cos much better than you know the antiderivative. So when you say this is sine x, the derivative is cos x. Yes. If you say this is cos x, the derivative is minus sine x. You say, oh wait, I'm going to need to change the sign here. All right, so what's the integral? So it's u times v, so e to the x sine x, minus the integral of v sine x du, which is e to the x dx. Well, now we've got another product. And so, we're going to go up here. And we're going to say, well, let's do the same thing, right? So we'll let u equal e to the x, and du will equal e to the x dx, and dv will be sine x dx. So what's v? Negative cos x. So we're going to end up running in circles here, but what happens is actually kind of cool. So this is u times v, which is going to be negative e to the x cos x, okay, u times v, minus the integral of v, so negative cos x, du, which is e to the x dx. And you say, you're going in circles, because look, you got e to the x cos x. You got e to the x cos x. So here's what we're going to do. I'm now going to actually write in the left-hand side. So the left-hand side was the integral of e to the x cos x dx. E to the x cos x dx. And that's equal to this. So e to the x sine x plus, okay, minus a minus, plus e to the x cos x plus, so minus a minus, oh wait, so minus a minus a minus, so minus e to the x cos x dx, minus that integral, right, the integral of. Now you can say, look, you got one of these over here, you got one of these over there. Can't cancel them out. But you're going to add this to both sides. If you cancel them out, you just end up with 0 is equal to that. It's not that. So you're going to say, hey, let's add this over here. Okay? So add integral e to the x cos x dx to both sides. So now I've got two of the things that I wanted to find. And that's equal to e to the x sine x plus e to the x cos x. All right, so if I've got two of the things I want to find, what am I going to do? Divide by 2, so I just get the thing I want to find. So the thing I want to find, which was the integral of e to the x cos x dx, is equal to a half of this plus a half of this. Plus, oh, we should have thrown the plus c in. Well, that, yeah. So that's kind of cool in that when you do it, you end up with another product. When you do that product, you end up getting back to sort of your original thing. It's like, hey, that's the original expression that I was trying to find the integral of. You could keep going, but you'd be in an infinite loop. Okay, so you don't want to, at this point here, you have to recognize, hey, that's what I started with. I don't want to start doing the UV with this because we'll just go into, and you can keep doing that forever. Right? But you say, wait a second, that's the same thing, well, with the exception of a minus sign, that's the same thing I had. So, you know what, let's just make sure we write this here, move that over there. Now we got two of them. And then we'll multiply both sides by a half, and then we've got one of them. Okay, question?
So when you see the similar term as the original, that's what you need to
Well, similar as in it's the same.
Okay.
It's the same, only it's a negative, right? So it's not like, okay, cancel it off both sides, at which point you end up with like a 0 equals, and now you've solved it for x. So you don't want to do that, right? We're not solving for x. We're coming up with an expression whose derivative is that thing there. Solving for stuff is like this. A definite integral is going to, oh, question?
Just had a question about the last one. If it's minus cosec dx dx. Can that be a plus?
So this will be a plus, but we got that minus out here.
Oh, I see.
So this is minus a minus, that's the plus, where that went here. So we got this, plus minus, yeah, so it's a minus. If it ended up as a plus, then we'd have a problem, because now we've got 0 equals, so it's like, oh, yeah, wait. That's a problem. Evaluate. Okay, I think this is the last thing, right? Last thing. After this, only 2 more lessons. So we're almost done. So, what does it mean if you're doing a definite integral? So what it means is this. If you have something of this form, a to b of f of x g prime of x, it is equal to, evaluated on this interval, minus f prime of x g. So it just means you're going to evaluate on the interval the first expression that you get out, which is just the u in UV notation, I guess. It would look like this. U dv would be u times v minus the integral v du. Okay, so if you're doing a definite integral, you're coming up with a number. Right, and this is how you can come up with that number. And you could, if you wanted, what's the notation going to look like here? Yeah, okay, let's not do that. All right, so I want the, well, okay, before we start that, so we got x cubed ln x, and ln x is the last thing we want to take the antiderivative of, right? So u is ln x, and du is 1 over x dx, and dv is x cubed dx, and so v is x to the 4th, so 1/4 x to the 4th. Again, just check that out, right? What's the derivative of 1/4 x to the 4th? 4 times 1/4 x cubed, or just x cubed. So anytime you take an antiderivative, so you're working in pairs, or whoever takes the antiderivative, the other person derives it. That's it. You got that right? It's okay.
So
Keep
what
going.
happens if someone makes a mistake? Whose fault is it?
You can assign blame later.
Well, why can't we cosine blame?
Well, yeah. Cosine. You could, yeah. Show me a sign. Okay, so that integral is going to be equal to u times v, so 1/4 x to the 4th ln x evaluated from 1 to 3 minus the integral over the interval 1 to 3 of v du, so 1/4 x to the 4th times 1 over x dx. And so we'll just keep the numbers on, yeah?
Can you not, like, after you take the antiderivative of the thing in integral sign, can you not put it all together?
Yes. That's where I was going with that line. Okay, I don't want to do that because I don't know. But yeah, we could do that. So for now, we'll just say 1/4 x to the 4th ln x minus, okay, what's this going to simplify to? 1/4 x cubed dx, right? Which is equal to, now we don't need a plus c at this point, right? Because we're doing a definite integral. So it's going to be 1/4 x to the 4th ln x minus, what's that going to be? (1/16), right? 1/16. And again, somebody is assigned, okay, wait, that's going to be 4 times 1/16, which is 1/4 x cubed. Yeah, okay, that's good. Okay, and at this point we can then say it's this expression which is going to be evaluated over the interval 3 from lower bound of 1 to an upper bound of 3. Okay, so we can combine that now at this point, all right? Or you can work this out separately and then write this. So you could kind of do this minus that, or you can just say, hey, it's the whole thing, so let's just do the whole thing. Get rid of that. Okay, which is equal to, so we've got 1/4 3 to the 4th ln 3 minus 1/16 3 to the 4th, okay, minus 1/4 1 to the 4th ln 1 minus 1/16 1 to the 4th. Okay, so we simplify that. So we've got 81 over 4 ln 3 minus 81 over 16 minus, okay, what's ln 1? 0, right? Okay, so 0. So this will then be plus 1/16. All right, so we've got 81 over 4 ln 3 minus 80 over 16. Now, 80 over 16 is 5. Okay, so at this point, it's now option time. So 81 over 4 ln 3 minus 5. 81 over 4 ln 3 minus 20 over 4, which is 81 ln 3 minus 20 all over 4. Okay, which you could, if you'd gone to this, so multiple choice wise, you're sort of looking, right? Written response wise, yeah, this or this. So like either one is acceptable, it's fine. Multiple choice wise, I don't see a 5 anywhere in the answers, but there's a 4, but they're all over 4. Oh, okay, let's make this 20 over 4, right? Or let's make this 20 over 4 so we can combine them. And you could do ln 3 to the 81 over 4 minus 5, right? I mean, that's like among the last things that I would ever do, but you know, it is a possibility, right? That can be moved up as a power. Okay, done.